So the new Anker 3D printer has been successfully funded on Kickstarter. Lord knows they didn't really need a Kickstarter. I'm sure they had the money for it, but everyone's talking about the default speeds and how fast it can print and all that. And I got to thinking, 250 millimeters per second with something like 2,500 millimeters per second acceleration. That's pretty good. But can an Ender 3 do that? Let's find out. So, of course, the first thing we're going to test out is a Benchy. Now, this is Kira running my own settings for the machine that I've optimized for it, just tweaking a few things. We're going at a 0.2 millimeter layer height, the 0.4 millimeter nozzle, 20% infill, and we're going to crank this bad boy up to 250 millimeters per second for the print speed. Now, the rest of it, we're just going to change all of that to 250 because why not? Now, Anker is saying 250 millimeters per second with 2,500 millimeters per second standard acceleration. Well, it just so happens that in Kira, we can change the acceleration without really having to go into the firmware, but we can do it firmware side if we really want to. So 2,500, let's just have all that taken care of, just kind of make this thing go nuts. Travel acceleration. Heck, why not make that 2,500 as well? And then for the jerk, it doesn't really specify what the jerk speed is, but I think we're going to up that to 10 for now. And we're going to go from there. Supposedly an hour and 32 minutes. We're going to see what this actually turns out to be. Okay, so to be fair, it's not exactly a stock Ender 3. It's all on linear rails. It's got a custom hot end that I had made, and it's basically just the Ender 3 frame at this point, but it's still an Ender 3, technically. I mean, the point is you can build an Ender 3 to be however good or bad you want it to be. It's just how much time and money do you want to put into it? Do the time and money we put into this one equate to something that is just as good as from Anker? Well, let's find out. So the Anker does a 7x7 bed mesh. So do we. Anker uses a PEI build surface. So do we. On this side it's the flat sticker, on the other side it's the texture powder coated PEI. The Anker uses a dual gear extruder. Granted, theirs is a direct drive. We got a BMG, so that should be fine. Theirs has got a high temp hot end. This is an all-metal hot end with a copper block. It's technically rated for high temp. So, I guess, let the race begin. Alright, first layer's going down. Now, for the first layer, I did specify it to go a little bit slower because I do want to make sure it goes down properly. But after that, we're kind of just off to the races, and we're going to see if this thing doesn't just completely destroy itself. So, in retrospect, maybe I probably shouldn't have had the combining mode to not in skin, because for the text on the first and second, third layer, it's kind of just going around everything, but I mean, we're going. I don't know what it's going to look like by the time we're done, but we're going to try. I mean, it's going. I don't know, maybe, I think we're melting plastic fast enough. It's not like we can't raise the temperature if we need to. But, I mean, I've never really pushed an Ender 3 to go this fast. Now, one of the secrets of this is we're using Gates Power Grip belts, which are fiberglass reinforced. So unlike a standard rubber belt, they don't stretch nearly as much when you've got the forces going in one direction and then the other. The Anker has a dual Y-axis belt system, which would further reduce that problem. But I'm wondering if just using a good belt to begin with and a decent metal tensioner is really all you need to make this Benchy happen. I mean, the machine doesn't appear to really care about this speed all that much. I wonder if I can increase the jerk setting and kind of make it accelerate a little faster. But we're trying to just match the Anker, not really beat it at the moment. Although things are going pretty good so far. We're on layers height 2.12 or 2.2 millimeters. Sorry, we're going in 0.2 millimeter increments. All right, so luckily on the Easy Board Lite, we can change the jerk in the firmware whenever we feel like it. I bumped it up to 12 to kind of see what would happen here, and we were at 10 before, according to Cura, trying to override the settings in G-code. But it doesn't seem to care. It seems like it's doing okay. I think at these speeds we're perfectly reasonable. So these layers are pretty fun. We're actually getting to see the machine really start to get a workout. We're doing the infill, and there's a lot of the grid lines for the infill, and I chose grid. So kind of get to see the machine just kind of having a workout here. It's going pretty good so far, better than I expected. So. Alright, well, we're nearing the end of the benchy. Now, we did not come in sub 1 hour. The whole print wasn't running on the jerk setting of 12. Most of it was 10, and then I just upped it to 14 right here to try and speed this along a little bit. It's going okay. I think part of my speed, if I'm honest here, is probably the first layer I chose to go pretty slow, and that combining knot and skin definitely made a lot more travel moves than was really necessary, costing me a lot of time. This isn't really like an official speed benchy or anything, not a speedboat race benchy, but just demonstrating that an Ender 3, if you build it right, can do the same thing that the Anker is claiming to do. Alright, official time, 1 hour and 12 minutes. That's not bad. Alright, so it's not the prettiest benchy in the world, but this is absolutely something that can be tuned just by adjusting some settings in Cura. It's definitely a benchy, though. Completed the benchy in about an hour and 10 minutes or so. Now, we were using a 0.2 millimeter layer height, and I looked into it. According to the Kickstarter, Anker was using a 0.1 millimeter layer height, so we could try that. Essentially, they did it in about 2 hours and 10 minutes at their 0.1, and our 0.2 was about half that time, so I could probably knock off that time just by doing some simple tweaks in Cura. But the point is, do you need that Anker printer, which is really making a huge deal over the sprint speed, to get decent results at that print speed? The reality is no, you really don't. And you can probably do it with just off-the-shelf parts, or even better, cheap parts that you can get online for probably less than what that Anker is going to cost after the early bird specials on the Kickstarter. I mean, let's face it, Anker knew what they were doing way ahead of time. They didn't need to make it a Kickstarter. They just do that to kind of create buzz and promotion around the printer. The Ender 3 can be made however you want it to. I'm not saying this is the end-all be-all of printers. It's clearly not. We've got a lot of fun upgrades coming to some other printers. But the point is, don't get caught up in the hype, because printers are way more capable than you might think with just a few tweaks and a few modifications here and there. You don't have to go nuts like we did with this thing, but there's some very simple things you can do to get to those speeds and not really have an issue. So that being said, thanks for joining us for the ride. I'll see you guys on the next print.